One day, humanity may become powerful enough to move planets. We may build cities around other worlds. We may harvest energy from the sun. We may send machines to nearby stars and still never explore the universe. That sounds too pessimistic. Because space stories usually move in the opposite direction. First, we leave Earth, then we spread through the solar system, then we reach other stars. Then, eventually, the whole galaxy becomes a human ocean. And after that, maybe the universe. It feels like a ladder. But the universe does not unlock just because a civilization becomes smarter. There are limits intelligence cannot negotiate with: distance, time, energy, light speed, expansion, and the possibility that most of the universe was never reachable in the first place. To understand this, start with the Kardashev scale. It is a way to imagine advanced civilizations by the amount of energy they can use. A Type 1 civilization uses energy on the scale of its planet. Humanity is not there yet. We use enormous power compared with ancient humans. But compared with the sunlight reaching Earth, we are still small. A Type 2 civilization uses energy on the scale of its star. This is where people imagine Dyson swarms. Not necessarily one solid shell around a star, more like countless collectors orbiting it and catching a huge share of its energy. That would make a civilization almost godlike compared with us. It could power worlds, move asteroids, and build habitats for longer than human history. Then comes Type 3, a civilization using energy on the scale of an entire galaxy. Billions of stars, millions or billions of inhabited systems. A whole galaxy glowing with purpose. At first, the Kardashev scale feels hopeful: planet, star, galaxy. But it hides a darker question. Even if we climb that ladder, how much universe would actually become reachable? Close enough to touch or to send a message and receive a reply? The answer may be much smaller than the word universe makes us feel. Start with Earth. For almost all of human history, Earth was the only physical world we could touch. The moon was visible. The planets were visible. The stars were visible. But visible does not mean reachable. For thousands of years, the night sky was a ceiling with lights on it. Then rockets changed that. Humans reached orbit. Humans walked on the moon. Robots crossed the solar system. That is one of the most astonishing things life on Earth has ever done. But compare it with the scale outside. The moon is a little more than one light second away. Mars can be light minutes away. The outer planets are light hours away, but the nearest star system is more than 4 light years away. So light itself takes more than 4 years to cross that gap. Our fastest spacecraft would take tens of thousands of years to reach that neighborhood with current technology. And that is the nearest star, not the far side of the galaxy, not another galaxy, the nearest one. This is the first uncomfortable truth. The solar system is not the beginning of a crowded cosmic city. It is an island. And the next island is across an ocean wider than human civilization has ever experienced. Maybe future technology changes part of this. Maybe we build fusion ships, laser sails, or tiny probes fast enough to reach nearby stars. Maybe generation ships carry people whose descendants arrive long after launch. None of that is forbidden in the same way faster than light travel seems to be. But every solution pays a price. Energy, time, risk, biology, radiation, and civilizations staying stable across journeys longer than recorded history. Crossing between stars is not like crossing an ocean. Interstellar space is colder, emptier, and less forgiving than any desert Earth has ever made. Still, let us be generous. Imagine humanity survives. Imagine we become careful, patient, brilliant, and lucky. Imagine we spread beyond the solar system. Nearby stars become reachable, then more stars. Then, perhaps over millions of years, much of the Milky Way. This is where people jump to the dream. A galactic civilization, humanity, or whatever humanity becomes, spread across the stars. But even that dream is not the universe. The Milky Way is huge. It may contain hundreds of billions of stars, but it is still one galaxy, one island in a much larger, dark ocean. The nearest large galaxy, Andromeda, is about 2.5 million light years away. Even if a civilization crossed that gap, it would still only reach part of our local cosmic neighborhood. The Milky Way and Andromeda are part of the local group. That small family of galaxies is gravitationally bound. So, our local island is larger than one galaxy. But beyond that island, the universe changes the rules. The space between distant galaxy groups is expanding, not just objects moving through space, space itself expanding between widely separated places. And because of dark energy, that expansion is accelerating. This creates a limit no engine can simply outrun. There are galaxies we can see because their ancient light has already reached us. But light they send now may never reach Earth. There are regions of the universe that are not merely far. They are outside what we can ever communicate with. This is the cosmic event horizon. It is not a wall. It is not a glass dome. It is a boundary made from time, light speed, and expanding space. If something is beyond that boundary, a signal sent today cannot ever arrive here. Not because our telescope is bad, because the space between here and there changes too much while the signal travels. This is where the Kardashev dream gets darker. Even a Type 3 civilization is not automatically a universe civilization. It may command a galaxy, but it cannot command the expansion of space between galaxy groups. The Kardashev scale tells us how much energy a civilization can use. It does not tell us how much reality remains accessible. Power is not the same as reach. A civilization can become unimaginably powerful inside one region and still be trapped by the structure outside it. Think about a human in a room. They can understand the moon and calculate its distance, but knowing does not mean touching. Now scale that up. A future civilization may map galaxies it can never visit, name worlds it can never receive a signal from, understand regions that can never know it exists. That is the tragedy. Not ignorance. Awareness without access. The universe may let us know enough to feel the size of the cage. And the cage is not only distance, it is also time. Stars do not last forever. Planets do not stay habitable forever. Civilizations must survive accidents, instability, and their own choices. The question is not only whether humanity can build better rockets. It is whether any civilization can survive long enough to become what the Kardashev scale imagines. And even if it can, many cosmic doors may already be closed. The night sky looks open. But openness is not the same as availability. From Earth, galaxies appear in every direction, but many are old messages, ancient light, surviving signals from places whose present may never become part of our future. This should change how we think about exploration. Exploration is usually described as courage meeting distance, but cosmic exploration is courage meeting physics. And physics does not care how badly a species wants the ending to be grand. This does not mean humanity should give up. The opposite. The limits make the reachable parts more precious. The solar system matters more, not less. The moon matters, Mars matters. The icy moons, asteroids, and nearby stars matter. If these are the places reality has placed within our possible reach, then they are not small prizes. They are the accessible universe. For us, they may be the difference between a species that stays on one fragile world and a civilization that survives beyond it. Maybe humanity never becomes type 3. Maybe we never fill the Milky Way. Maybe we never reach another living world. But even preserving life beyond Earth would be a cosmic event. Because as far as we know, life is rare. A species able to understand stars and worry about its future may be rare. So the sad truth is not that humanity is meaningless. The sad truth is that meaning does not remove distance, like curiosity does not remove light speed. Hope does not stop expansion, and intelligence does not guarantee access to everything it can imagine. There may be civilizations far beyond our cosmic horizon. They may build art, ask questions, and look up at their own sky. And we may never exchange even one hello, not because we failed, not because they failed, because the universe can contain places that are real and still permanently unreachable. That is the dark side of the Kardashev dream. The ladder may rise from planet to star to galaxy, but it does not necessarily rise to the universe. There may be no final level where civilization owns all of space. There may only be islands, some lit by one star, some lit by billions, and between them, distances that no story can soften. So maybe humanity's future is not to explore the universe. Maybe it is to understand the universe from the tiny part that can answer back, to learn what we can, reach what we can, protect what we can, and accept that reality is larger than any civilization's reach. The universe may be full of places humans can imagine, measure, and name, but never touch.